Hi, everyone. Thank you for joining today's webinar on cloud monitoring with LiveAction. I'm Monique Lucy, Director of Product Marketing here at LiveAction, and your moderator for today. So if this is the first time joining a LiveAction webinar, I just want to make a quick introduction to LiveAction's network performance management solutions. Our solutions enable network teams to achieve operational and performance excellence to support business success. With LiveAction Network Management, teams are able to improve application performance, accelerate troubleshooting, and manage their network readiness. They can deliver major cloud migration initiatives and perform advanced reporting and analysis. So on our panel today, we have members of LiveAction's sales engineering team. These are the people that are working hand in hand with customers every day to resolve the toughest network issues. We'll hear from David Izumo, Principal Technical Marketing Engineer, and Ryan Grandy, Sales Engineer here at LiveAction. Welcome, everyone, and thank you for being with us today. David and Ryan, please feel free to introduce yourself and give us a bit of your background.
Sure. Hey, everyone. Thank you so much for joining. My name is David Izumo, and as Monique mentioned, I'm a principal engineer in technical marketing. I've been with the company for quite some time, from the very beginning of when LiveAction became a commercial company. I'm looking forward to working further with all of you. And then also, it's been a wonderful benefit to see how LiveAction has been progressing over the years, solving a lot of the biggest network challenges from a monitoring perspective. So thank you very much for joining.
Thanks, David. And as mentioned, my name is Ryan Grandy. I'm sales engineer. I have been with LiveAction now going on just about 2 years, but I did have the privilege of using the LiveAction suite of software in the corporate environment in my previous life, where I did a little over a 20-year stint as a network engineer and architect before coming over to this side of the house. So looking forward to talking to everybody today. Monique?
Thank you both. Before we dive into our main topic of cloud monitoring, let's just take a quick look at the macro trends that are impacting network operations teams. One overarching theme is the network continues to increase in complexity. More and more businesses have a multi-cloud strategy, around 93%. SD-WAN is becoming increasingly pervasive, and adoption is increasing. In fact, about 94% of customers say that they'll deploy SD-WAN within the next 2 years. And both of these factors only increase network complexity that network teams must operate and support. And ultimately, network teams are not keeping up. About 73% of organizations are struggling to maintain the status quo rather than being able to future-proof their networks. So when we first engage with enterprises, we often hear some common challenges due to this complexity. Things like disparate tools and data sets for today's network, painful and time-consuming troubleshooting process, difficulty making sure the network can meet changing business needs, challenges meeting service levels due to application and network interdependence, and an overall lack of visibility into the impact of network change initiatives. Reporting on NetOps activity and performance is also very time-consuming, and there's just an overall lack of trending and baselining, which puts NetOps in reactive mode. Added to that complexity is the fact that for many organizations, the migration to public or hybrid cloud is no longer a thing of the future. 43% of network managers say their NetOps strategies are driven by public cloud initiatives today. On average, 40% of all traffic on an enterprise network is attributable to cloud-based applications and services. And 61% of network managers say that their tools are less effective at managing and monitoring in cloud than they are at managing and monitoring on-prem networks. So network managers who have tools with excellent cloud support are more likely to say that the network operations organization is successful. But cloud migrations are fraught with challenges. So I'd like to hand it over at this point to David so that he can dig a little bit deeper into these challenges.
Thank you very much, Monique. So what are some of the challenges with public cloud? Network engineers find it very difficult to visualize how traffic traverses cloud networks. It doesn't easily map to their typical mental model or the way that they think about the network. There's a lack of end-to-end visibility in a single pane of glass to understand application traffic from on-premises to the cloud and vice versa. Now, this diagram that we're showing really helps us to understand some of the challenges with cloud visibility. Network engineers need to see how cloud entity instances like EC2 instances or virtual machines, how they communicate with one another within the same subnet. There are challenges with inter-availability zone traffic to understand how the back-end application, for example, communicates with a cloud database service in another availability zone. On-prem to cloud visibility is important as traffic traverses virtual private gateways. Being able to tie in the data center, the physical data center, to the cloud, that's definitely a challenge. There are challenges with visualizing how internet traffic goes in and out of a VPC or a VNet, and how we can verify that everything remains secure, especially in this day and age. And along those lines, around security, there are difficulties in validating security configurations, for example, ACLs, with real-time accepted, rejected traffic in a format that is simple and easy to explore and explain. The fact of the matter is, our customers' IT teams, they need better visibility into cloud deployments. Cloud migrations from on-premises data centers into the cloud is critical to the modern business. In fact, in just a little bit, I'm going to go into a use case, a customer use case, on how they're tackling that challenge. Cost plus consumption analysis is key to keep spending under control. And monitoring and troubleshooting hybrid IT environments with multi-vendor virtual and physical resources is critical. And of course, security is very top of mind for many IT teams throughout the industry. So next, let's take a look at LiveAction, LiveNX, and the approach that we took to cloud monitoring. Now, the diagram on the right-hand side for cloud networking can get complicated very quickly. There are new concepts that network engineers are not very familiar with. For example, cloud regions, availability zones, VPCs, VNets, and so forth. Now, if we, as LiveAction, expect network engineers to monitor cloud networks seamlessly, we need to instrument LiveNX in such a way that it's easily recognizable and so that network engineers can comprehend it simply. With LiveNX, we abstracted a VPC or a VNet to be visualized like a router. The VPCs can have multiple subnets hosting virtual resources, just like a router has several interfaces tied to different subnets. Some interfaces on a router connect directly to the WAN or the internet, for example, like a virtual private gateway, a VGW, or an internet gateway, an IGW. As a result, we can track traffic coming in from a remote site into a VGW and then out toward the cloud AWS or Azure public subnet, as we see in this example, and the resources within the cloud, just as if it's going through a router. Again, the goal is recreating the mental model of the way that you, the network engineer, thinks about the network. So how do we provide this level of visibility? LiveNX queries for flow logs in AWS and Azure, and then we augment that data with information we retrieve from cloud APIs like AWS CloudWatch, for example. Now, this allows us to understand and present to our customers the conversations within a VPC or a VNet and going in and out of a VPC or VNet as well. Along with that, we can also provide further context from the cloud APIs. We add information such as the cloud service, the availability zone, the region, and whether or not the flow was accepted or rejected based on security policy. From our long history of flow analytics, we also provide additional value add from a flow perspective. Things like deduplication, application information, DNS, and country mappings as well. We really want to be able to provide visibility into where this traffic is going, what the users are accessing. From a country mapping perspective, it helps with use cases to understand which various countries are actually coming to your VPC or VNet, and also whether or not your traffic, your security policies are enacted in just the way that you're thinking about, rejecting traffic maybe coming from a country that you do not want access to your cloud network. Security is always of interest, identifying all traffic entering into the VPC and so forth. So together with LiveNX's capabilities of managing traditional network devices or SD-WAN edges and the cloud, we can easily track traffic to and from on-premises devices hosted within your data centers or your various branches and sites to the cloud in a single pane of glass dashboard. One very large global pharmaceutical company that we're working with is quickly migrating to the cloud. In fact, today, 80% of the applications are on premises and 20% in the cloud. In as little as 18 months, these numbers are going to be reversed. 80% in the cloud, 20% on premises. As a result, end-to-end visibility during migration and post-migration is critical for business success. That visibility, they absolutely need it. They're using LiveNX during the transition to help baseline their current application health and load, thus being able to better be prepared for their SD-WAN and cloud deployment, including service provider load, application latency, which application should get preferential treatment, and QoS health. Post-migration, it's all about operationalizing their SD-WAN and cloud networks. They validate user experience and establish new baselines for ongoing day two operations. The importance of quality of experience tracking for the end users is very critical. So with that, I'd like to turn it over to Ryan, and he'll be helping us with a live demo to see how we can put all of this into action. So Ryan, please take it away.
Perfect. Appreciate it. Let me bring up the demo system here so that we can start looking at what it looks like in the real world here. So we have several different interfaces. I'm going to start with the engineering interface just because I think it's the easiest interface to really kind of give you that peek behind the curtain. So one of the greatest things about the integration that we have is that we're able to tie the information in from the cloud the exact same way that we're already able to present information from your traditional environment, whether that's an SD-WAN environment, whether that's what we would now consider a legacy WAN environment. So what we're looking at here, you can see devices, and as David had mentioned, we treat the VPC as if it was a device. We abstract it so that it just looks like another router, switch, firewall, wireless LAN controller on the environment, which allows us to then place it and all of its information side by side, as I was saying, with the information from your regular network. Now, in this particular view, we're just looking at traffic as it flows from our local area network all the way up to the cloud and back. And now we can start to filter this or look at this in different ways. And if I click here on the table, for instance, it allows me to see a list of all of the data that's moving across the environment. But what I really like about this is if I do see an application or a particular flow or I'm looking for something, if I double click on it, what it's going to do is it's actually going to go out and it's going to pull information from all of the different devices on the network that it sees this particular conversation moving across. So now I'm actually able to see this traffic along with information about what interfaces it's traversing on its way from my LAN across my switching environment and even all the way up into the cloud itself, including which interfaces it was traversing. So again, if you have multiple paths into your cloud, you have maybe a direct connection, maybe you have a VPN connection, et cetera, or maybe it's supposed to be, an internet publicly available address that you're accessing. You're going to be able to see all of that information here so that you can be sure that your traffic is taking the path that you intend it to take, and all the way right up to the actual subnet that the device and the actual device itself that you can see down at the bottom of the screen that the traffic is terminating at. In fact, if I really wanted to isolate that particular conversation, I can take it one step further, and now I've eliminated all of the background noise, and I can see just this one particular conversation and all of the different interfaces that it traverses. So speaking of those interfaces, let me zoom in here a little bit on this particular device. And this here is what we've done when we abstract a VPC. So all of the different interfaces here that are represented by smaller circles, these are going to be things like all the different services that you might have. So here you can see an IGW and a VGW in this particular case, as well as rejected. And then all of these different subnets are going to be all the RFC 1918 addresses that you have registered within your particular VPC. As I zoom back out a little bit, you'll see that in this particular case, we're looking at AWS. So I have this particular VPC and any other devices that might be listening to it. David did make mention of the fact that we're working towards being able to take advantage of traffic mirroring within the cloud to be able to actually do packet capture and get information from that perspective as well. But if you have multiple VPCs inside of a region, you're going to be able to cluster those together visually, as well as if you did, for instance, have some specific needs. Maybe in addition to clustering it into regions, you also want to cluster it into availability zones. We have this concept of semantical tagging that allows you to assign arbitrary tags to the particular devices that you want to assign tags to. This can then be referenced for later filtering. So if I did want to break things down by AZ, or if I wanted to break it down by region, or maybe I have certain components of my applications within certain types of VPCs, or they're segmented by application type, et cetera, then you can actually go ahead and have that tagging in place here. And you'll be able to reference that not only for looking at the traffic and the views that I just showed before, but also in looking at that traffic from reporting, which we'll go over in a few moments. Now I'm going to go ahead and I'm going to double click on this device. And again, this is a VPC here. And now once again, you can see I've got access to all of the rich information that we're actually pulling down from the cloud itself. And that information references the interface. It tries to identify the application. And if we see something of interest, all we have to do is right-click on it, and then we can drill down into more specific information. Or maybe I want to filter on this particular application and see, hey, what exactly is going on? Who's using this application? We can also take it one step further without necessarily having to run reports. And maybe I want to say, hey, I just want to see all of the traffic that's coming in from the internet. So because we break the different networking components down, like the IGW and things like that, to interfaces, it means that I can actually go up here and type a command as simple as interface equals, and then I can put IGW. And now if I hit enter, what it's going to do is it's going to filter all of this traffic right here. And now I'm only seeing traffic that's traversing that particular interface. Likewise, we can do that exact same thing with, say, the rejected. So again, if I just type interface equals and rejected, I can go ahead and hit enter. And now what should happen is all of the traffic that's actually coming through that particular interface, if there is any, there it is, will be reported up on the screen right here. Now it's important to know I'm a CLI guy, so I like to type things. Clicking on this question mark here brings up an index of all the commands. But everything that we do is also context aware. So what you see where you click matters. And again, that comes down to simplicity. So for instance, as I scroll through here, you can see I've got IGW and private 1. If I only wanted traffic that's moving through, moving from or coming to the private subnet here, I could right click on this and I can just apply that, and it'll actually go ahead and it'll build that particular filter for me so that I don't have to learn the syntax. So, very, very simple to use. Now, this is great, and this is good for live troubleshooting. Allows me to very quickly and easily understand what's going on. If I move back to that previous screen, it allows me to understand how my traffic is traversing not only from my on-prem equipment, my end users, as well all the way up and through the cloud. But it also allows for us to do a lot of very rich reporting. And while we can just click inside of this interface and access the reporting, I do want to showcase some of the views that we have pre-built into the actual web interface as well. So I'm going to pivot out of this and switch to my web browser. And this is our HTML5 interface. Now, the nice thing about the HTML5 interface, it's fast, it's modern, and you don't have to install any clients to get into it. So it's very quick and easy for lots of different people to access. And then you can have the thick client reserved for the deep dive troubleshooting that might be done by your higher level engineers. Now, this particular view is our overview. It is a kind of a view that you could leave up on a monitor. If I click in this upper right-hand corner, it'll auto-refresh this page once a minute. And it's perfect for a NOC view. But we also have dashboards and other views that are perfect for looking at a NOC. But what I want to do is I want to show some of our, like a troubleshooting flow. For instance, if I know that I have an issue with a particular VPC in a region, I can just click on Sites here, and that'll take me to my Sites view. And then I can go ahead and click whichever cloud provider and or region I want to look at. In this case, I'm going to click on my AWS Oregon region. And now it takes me into a site view that gives me access to lots of information. Again, I have a site details view where I can actually have useful information about the addresses that are associated with this particular region and or cluster of VPCs that are present. Again, all about giving quick access without you having to bounce around looking for this information that you might need when you're doing troubleshooting. On the right-hand side, I have a little bit of a topology diagram. And this is nice because if you do have lots of VPCs associated with the region, in this particular case, I only have one. But if we had lots of VPCs or VNets in this particular cloud region, it would show all of those up here and would allow us to then potentially pivot into more specific information from one particular VPC or another that's within the region. And then down here, we also have our LiveWire. So if I was, looking at this particular view, and again, I can set the period of time that I'm looking at in this particular view here so that it brings that information together over a period of certain predetermined time. If I wanted to pivot to the packets, for instance, I'd be able to click on this, and there'd be a link in here to take me to the packets based on whatever it is that I'm viewing. But in this particular case, we're looking at all the information coming directly from the cloud right now. And this is that typical information that you'd expect to need when you're trying to do that initial troubleshooting. As I scroll down the screen here, you're going to see we have things broken down by top applications, both inbound and outbound. And that's important to know. We're aware of the need to understand directionality around your applications, not just for troubleshooting, but also for trying to plan the expenses. And we'll get into that a little bit more when we look at the actual reporting flows. And here we'll see DSCP again. You need to protect your applications if you're going across the internet and or especially if you're going across some other connection type. You do want to make sure that these applications are clustered in a way that makes sense and protected as best as possible from a quality of service standpoint. It's traversing the various parts of your network. And top conversations views as well, again, with both inbound and outbound available. But I think one of the important views here is really going to be the reporting. So if we click on down here, go into our reporting views, here's where we can start to customize and make these views that are going to make sense for the type of troubleshooting that you're going to need to do. In this particular case, maybe, let's start with a traffic composition. So I'm just going to run a little 15-minute report here. So I'm going to click on one of my templates. And it's important to know that you can stack different types of information that's going to be important to you in all of our reports. It's one of the greatest things about our reporting, lots of options for filtering and things of that nature. But if I go ahead and I execute this, what it's going to do, it's going to go out, it's going to pull all the information over whatever the predetermined period of time is, and then display that information to me with details about the different reports and sub-reports that are inside of this stack. So for instance, here you can see we're looking at a 15-minute report, and we're starting off by looking at it by application volume, by total bytes. So I can see, okay, which of my applications is eating the most bandwidth, for instance. And again, if I see something that maybe doesn't make sense or I want to know more details about it, even our reports are interactive. So for instance, if I wanted, again, to pick on this particular application, I can right-click on it and pivot to just the top conversations for that application so that I can understand who it is that's using my applications as well. And you're going to see that all throughout all of our interfaces. It's all about context awareness. It's all about ease of use. And again, that same breakdown, inbound versus outbound. Moving down a little further, you can see that I also have it broken down by top talkers. Again, maybe I'm a little less concerned at the moment about what applications people are using. I just want to know, from a trending standpoint, who are my top talkers? What are my top servers that might be accessing it or my top clients? And again, likewise, if I did want to know, okay, here's one of my top conversations, but I want to know what applications it is that they're using. Just a simple right-click on it, and now I can pivot down and look at the applications that are making up this particular conversation. So very simple, ease of use. We talked about security, so obviously let's pivot over and look at that. So I'm going to do the same thing. I'm going to click on my security report here, where again I've got information broken down by rejected applications, rejected conversations, and again a breakdown by country. All of the things that you're typically going to expect to be looking for from a security standpoint. And this is actually a good thing. So here we see unknown. If I right-click on this, I can pivot out to, a conversation view and start to understand what is it that's going on? What is making up this unknown application? We obviously find that a lot of applications in the cloud are going to be proprietary, homegrown, home-built applications inside of your private cloud. So we have very easy ways, both in the thick client, and I'm going to show the thick client way to approach this, to define an application. If I come into my VPC and I happen to see an application that, for whatever reason says unknown, or maybe it just says here HTTPS, okay? I can come in, I can right-click on this, and I can define a custom application. And it'll grab the information that it needs to be able to give that a name. So now anytime I run a report or anything like that and I look at this, okay, this particular application, this cluster of servers, or this particular subnet might be associated with this given application. So it makes it very easy and very quick to get rid of those unknowns, which again is one of the reasons why we have these reports. So you can come in and say, hey, I have something that I need to identify further. I can right-click and start pivoting into that and use a workflow, whether it's in the web or whether it's in the thick client, to identify those. Again, you can see top rejected applications, and then finally down here, we've got a breakdown where we're looking at it by country. So the type of information that you're going to want just from a high overview or a troubleshooting standpoint from a security point of view. So obviously I can take up an hour going through all the different features and covering everything, but I did want to make sure that we covered it at a high level and still had some time to pivot back and focus on any questions that anybody might have. So that having been said, let me stop sharing at this point, and then I will pass the ball on back to you, Monique. All right.
Thanks so much, Ryan. That was great. So I will just quickly summarize what David talked about a little bit earlier. There are some key challenges with public cloud. Network engineers find it very difficult to visualize exactly how the traffic traverses cloud networks. It doesn't easily map to their typical mental model. There's a lack of end-to-end visibility and a single pane of glass to understand application traffic from on-premise to the cloud and vice versa. So how does LiveAction help network teams? So we provide visibility at all levels. We consume more data at a granular level than anyone, allowing you to start globally and then drill down to a location, a single hop, a packet, or even a phone number, all from a single pane of glass. LiveAction is different from other network management tools because we provide end-to-end network visibility in a single pane of glass across the entire network, including campus, branch, data center, public cloud, WAN, SD-WAN. And we're vendor agnostic, and we offer the broadest support of key network vendors and the broadest telemetry, including NetFlow, Packet, SNMP, API, IPFix. We have an enterprise-scale platform with real-time and historical monitoring without compromise. We also offer unmatched data fidelity and the finest level of granularity, with predictive analytics to proactively identify, troubleshoot, and resolve network performance issues, leveraging both AI and ML. So I'll pause there, and we'll take some questions from the audience right now. Let me see what we have for questions here. So we've got a couple of questions. One is, are the time frames for the reports configurable? Can a report be generated for 7 days, 30 days, 1 year? And what are the roll-up policies and side effects?
That's a very good question. If it's okay, I'll go ahead and take that one. Absolutely, all of our views have the ability to adjust the timeframes. The web views that I was in, not even the reporting, just the typical views, the site view, there was a little Wayback Machine in the upper right-hand corner that allowed for some pre-selected views for that particular view. But the reports, those you can select down to 1 minute. So if you wanted to we've got some pre-built menus in there to make it quick and easy. So I think we've got 15 minutes, 1 hour, a day, a month, and a year. But you can select custom, and you can actually choose any particular block of time. And no negative side effects. I mean, we'll approach things from a 1 minute aggregate type of a bucket view. And then if you do go longer, you will automatically switch to a 5 minute bucket, but you typically have the ability to go back down to a 1 minute average just to make sure that you have this, the desired level of granularity.
And I see we have another question here. What cloud platforms does LiveAction support?
I can go ahead and take that one as well. At the moment, we're currently able to monitor information from both AWS and Azure, and we're expecting to have Google Cloud added into that mix as well by the end of the year. And then we're also working towards, as I'd mentioned, and I believe David had mentioned as well, bringing packet capture into the fold. So we're looking to be able to take advantage of VPC traffic mirroring. Again, sometime before the end of the year. We're already doing our testing internally and just making it run through the paces to make sure it's going to do everything we want it to do. And then once Azure goes ahead and stabilizes whatever it is that they're doing, since they keep adding and pulling the VTAP, we'll go ahead and kind of work towards doing that with Azure as well. And I'm not actually familiar with whether or not Google has the equivalent of traffic mirroring in VTAP, but obviously if that feature set's there, we'll be moving towards that as well in that order.
Thanks, Ryan. Another question here. Are the reports exportable to other formats, Excel, etc.?
They are. All of the reports that we have in place can be downloaded as a CSV. And then we also have the ability, when generating a report, to download it as a PDF. And of course, they're available via the API as well. So if you wanted it in JSON for easy parsing and things like that, you can also access all of the report information output from our API as well.
Excellent. Another question here. What is the retaining time of the LiveWire packet trace?
So if we're looking at the packet side, obviously it's a moving target. It depends on the amount of traffic that is being mirrored into the box and the amount of storage space that you've allotted to it. So obviously when we're dealing with virtual appliances, you can allot as much space as you want. The more space you have, a little bit slower the reporting and processing is going to be, but no easy answer to that. It's really going to matter. It's going to be a little bit of math between the rate of which you're sending information to it, as well as the rate or the amount of storage that you've allotted. Now, if we're also talking about the flow data that we're getting, because that's an important differentiator. When we do capture packets, we're also going to generate telemetry from those packets, and we can hang on to that telemetry data again, really with no limit on how long you want to store it. So again, it's just going to be a matter of what those flow rates are going to be versus the amount of storage that you have, and that's the same way we deal with traffic on-prem as well. We're going to bring information in from all the different sources, various different types of devices, routers, switches, firewalls, wireless LAN controllers, anything that can generate flow. And we're going to aggregate that information, and we're going to make it available for both visual analytics as well as reporting, and of course alerting and things like that.
Thanks, Ryan. We have another question here. How does it link the traffic that goes through a load balancer and NAT/PAT? Does it look at the payload in order to match sessions?
That's a good question. We're always piecing information together from various types of flows. It's a big part of what we do. And because of the information that we're getting, not only in terms of the flow data, but also the information from the API, we know where the next hop's going to be. So it allows us to figure out what that next step is going to be from a visual analytics. And then likewise, again, keep in mind, at the core, that's all our product does. We're constantly bringing tons of information from lots of different routers, different switches, different devices. And because we abstract and treat the cloud just like any other device, it allows all the algorithms that we use to bring flows together across all these different devices together in a single view anyway. So the nice part was there really wasn't any special sauce or magic that we had to come up with to make that happen. It's what we've been doing all along.
Great. That's great, Ryan. I have another question here. How does your solution work in a hybrid IT or even a multi-cloud environment?
That's a good question. David, you want to take that one, or should I run with it as well?
Yeah, why don't I take that one, and feel free to add on, Ryan. Yeah, so from a hybrid IT environment, definitely LiveAction, LiveNX can help you, especially tie things from on-premises. We accept flow. We make connections to devices via SNMP, and then also from the cloud, like we were just talking about here on this webinar, via the flow data, flow logs, augmenting that with CloudWatch APIs or various other cloud APIs. So from a multi-cloud perspective, LiveNX has many different deployment scenarios also. A single LiveNX server could monitor both AWS and Azure, and we can deploy in the cloud as well, directly in those environments. And then likewise, one other comment I want to mention with regards to cloud and multi-cloud, we're talking specifically around cloud monitoring for AWS, Azure, and then in the future, like Ryan mentioned, Google Cloud Platform as well. But many of our customers are deploying or working with SaaS applications also. And from a passive performance monitoring perspective via IPFix or NetFlow, we can consume data to understand performance to and from SaaS applications via Cisco iOS and iOS XE, and likewise with our Livewire offering too. We can pull together from the packets. We can generate IPFix or flow, just as Ryan mentioned, and we can pull application performance data from that to understand SaaS application performance, or also traffic performance going to your cloud infrastructure like AWS or Azure also. So hopefully that helps.
Thanks, David. That's great. Another question here. What is the pricing model for LiveAction? I presume it is a subscription model, but how do you calculate the cost for a customer usage?
David, you want to take that, or you want me to take it?
Ryan, why don't you go ahead?
Okay. So for the cloud aspect of it, we bill based on what's called a cloud entity count. So we know that there's an extremely dynamic nature to the number of devices, instances that might exist out in the cloud. You know, maybe there's a high tide at which you take advantage of elasticity to automatically and dynamically spin up additional resources. Likewise, we know there's going to be low tide, periods where servers either may not exist at all or might just be dormant and not actually doing anything. So to minimize the expense to the customers, we do what we call a cloud entity count, which basically takes a look at the flow data that's coming in and then analyzes it to pull an hourly average of the total number of unique IP addresses that we see from the RFC 1918 and or private addresses you own inside of your particular deployment, inside of your private cloud for each of those VPCs. And then we'll go ahead and, based on that particular number, determine what that license number would be. So for the cloud, it is by unique IP addresses that are going to be conversing simultaneously at any given point in time. So we typically find that it ends up being, if you were to go ahead and if you had a fairly static deployment, we probably see that maybe about 60% of those particular devices are ever talking all at the same time. So kind of a rough estimate on where that would be. And then from your regular devices, your regular infrastructure, since we monitor that as well, it's based on device. So it's nice and easy. Just like on the one side, we're looking at the total number of private IP addresses that you own and that are talking at any given moment. On the private side, we're actually looking at just the devices. That's basically, think of it as the source of flow and polling data. So if you have a stack of switches, that's one source, hence one license. If you have a chassis switch, with 10 blades and 1,000 ports, it's still one license. And then routers, switches, each of those types of things, it's all one device license. And that's it. We don't upcharge based on rate. We don't upcharge based on types of interfaces, number of interfaces, the amount of flow that's coming out of it, none of that. So it's a pretty straightforward and easy to understand format.
Thanks, Ryan. We have another question here. Can reports be scheduled to run at a specific time and the results emailed?
Oh, great question. Absolutely. Yeah, all of the reports can be scheduled right down to the minute when you want them to run. And then as soon as that report's completed, it will either be able to sit inside of a holding queue on the web interface in the reports history for you to go and retrieve. Or again, you can have that delivered via email. And you also have the ability to choose whether you want it delivered as a PDF or a CSV format. Excellent question.
Thanks again. Here's another one. I heard several instances of telemetry on our top day sessions, on today's sessions, but does LiveAction actually support actual telemetry data, model-driven, cadence-driven telemetry data?
So when we talk about telemetry, we're talking about flow and all of its different flavors. So S-flow, J-flow, you pick a flow type. It's going to be some format of NetFlow. We do SNMP polling for devices that are capable of supporting it. And then obviously we deal with some proprietary flows, some security flows so that we can understand information from the firewalls and then the flow data that we're able to digest from the logs here. So that's kind of where we're limited to in terms of the way that we look at it. And then obviously the flow data that we're actually generating ourselves from those packet capture appliances that we talked about, both being able to do on-prem as well as virtually up in the cloud.
Great. Thank you, Ryan. So that looks like all that we have for questions today. So with that, I would just like to wrap up by saying that you can get more information here by, you can take another look at this particular cloud migration session or share this with colleagues. You could also request a one-on-one LiveNX demo session, or you can click here to download a LiveNX free trial.